All right, welcome everyone. Welcome and a talk about continuous deployment using Spinnaker. Who am I? I'm Andreas. I come from Belgium. I'm a solution architect, hands-on, and I love to use open source and contribute to it from time to time. I work for a company called Ordina, which is more like a local consultancy firm. And what do? We try to help companies evolve to the cloud, to a new architecture. So there are three parts of a digital transformation that we see. Is firstly embracing a culture of DevOps, best practices, making sure that we cross those boundaries between Dev and Ops, but also business and security and what have you. And then once we have that culture, we can start looking at the architecture. And the architecture has to become more modular if you want to go faster. If you want to go faster to the market and faster to value eventually. So adopting microservices is something that we really look into. Obviously not always dogmatic, try to find the right fit. But we see that there's a trend that people kind of want to move to microservices to go faster. And if you have these microservice components, obviously you need some kind of platform to support it, right? Some infrastructure. So they move to the cloud. And once they do that, they see that there are a couple of things that become harder because of the scale, because of the modularity, because of the abstraction levels of cloud that might differ between clouds. So while we were doing this at various companies, we learned a couple of lessons. We saw that some things are indeed really hard. And the lessons that we learned, I'll share some of them. First of all, is that the deployment frequency kind of exploded. Being able to use a platform as a service, or at least an infrastructure as a service, allows you to go a lot faster and kind of iterate on the functionality a lot more quicker. And that's kind of hard to keep track of. Like these normal release cycles that we used to have, once in 3 months, for instance, that was kind of in the past, right? Right now, we kind of deploy multiple times a day. And if you look at companies like Netflix, they deploy 4,000 times a day. And that's increasing 100% year over year. Right? So that's just insane. So project managers, that kind of stuff, it's kind of irrelevant at that point. It really has to go a lot quicker. And managing that complexity and that rate of change, it's a new challenge. Right? So that's something that we learned. We have to pay attention to that. We have to keep allowing teams to go faster by giving them tools and processes that will still give the same guarantees as before, but with this new model. We also saw that it's not always just one cloud that we're deploying to. Sometimes cloud deployments can become really complex if we use multiple availability zones, multiple cloud providers. And we see, for instance, in this animation that you can have a lot of different people constantly creating changes on a number of services. They might not be related, or they might be. And that has to be synchronized and has to be managed across multiple providers and multiple availability zones and regions. And maybe even multiple accounts. If you have specific billing set up in separate accounts on the cloud providers, it gets kind of hard to get a sense of what's going on. If you have an application that's deployed on multiple clouds, multiple regions, then it's important to get a holistic view of that situation, right? To really see where is my application currently running, how many instances, what's the health of those instances, how much traffic are they currently receiving, and if there are new versions that you want to deploy, how are we going to roll that out? And that's much more complex, right? Obviously. And when I'm talking about providers, if you have an on-premise installation, maybe an on-premise Kubernetes, for instance, that's also like a private cloud, right? I mean, you also have to kind of combine that with your public cloud deployments. So that's a tough one. We saw also that because we deploy that frequently, things might go wrong sometimes. We don't have these big meetings where we gather everyone for a whole weekend, and then we try to release something into production, and we just hope that everything is going to be fine after the weekend, right? we don't have that anymore. We just deploy every day constantly, and we have a fraction of time to make sure that everything's fine. And for that, we need quick rollbacks, easy rollbacks, deterministic rollbacks. We need to make sure that we can go back in time and have no consequences. Right? So we can kind of have that that experimentation thing going on, right? Where we just test out new things, and we are pretty sure that it's going to be fine. If things go wrong, we can still roll back. Okay, so we have to make sure that we have the infrastructure, the tooling in place that allows us to roll back in an instant. Okay, that's important. And I don't know if anyone knows this one. Anyone has seen this one? Yeah, one guy. From which one is this? From which site is this? GitHub, indeed. So the idea of GitHub is when the site goes down, we show this unicorn because it never happens, right? Unicorns don't exist. So that's the idea. We have to try to make sure that the blast radius of our issues becomes small, that we don't impact a lot of users when things do go wrong. And deploying during the right time frames is an important part of that. So you can look at, like, for instance, when your traffic is low, then maybe you can already do some stuff up front, but the real deployment can happen at that downtime or the lower traffic. That's one thing, but also we have to combine that with when people are actually in the office, because that's the downtime is, or the low traffic is often when we're sleeping, and you don't have a lot of people in the office then. And making sure that DevOps is sustainable also means that you kind of have to make sure that people don't quit their jobs, right? So aligning those two things is it's an important part as well. Just because we can go fast doesn't mean, or we can deploy at any time doesn't mean we have to deploy like at night, for instance. So these lessons that we gathered, they kind of drill down to some principles, some continuous deployment or delivery principles that we always have to try to aim for. In any tool that we choose, I'm talking about Spinnaker today, but whatever tool you use, these principles are important to get right. If you get these principles in your pipeline, then you should be doing a good job, I hope. So these principles, first of all, I'm sure you've seen this principle a lot of times already in presentations. Immutable infrastructure. Now, this is an important one, I suppose, because the deterministic nature of deploying, testing, building, and validating your changes, it's an important part. It's a really good thing to have to make sure that you can count on what you expect to happen will actually happen. Okay, so it's kind of this predictability, and you need to be able to repeat yourself really quickly because you have these faster time to value constraints. I mean, you have to go for that. So making sure that's repeatable and you can do it fast is an important part. And immutable infrastructure gives you this advantage. And you can do that through baking images or containers. So for instance, if you're on the cloud, the Amazon images or Google Cloud images or Azure images, and you can also use Docker containers, I think, on all of those clouds. So that's a way to make immutable infrastructure happen. If you combine that with deployment strategies, I think having these containers is one thing, but rolling them out in a certain strategic way is an important part as well. You can just deploy something like in a red-black fashion, blue-green fashion. Red-black is actually from Netflix back in the time where they had a logo which was red and black. They call it the red-black deployment, but it's actually just refers to blue-green. So what do we do there? We kind of spin up the new instances next to the existing one. So you have two server groups, and you use a load balancer to just switch between them. Okay, that's straightforward, and it's easy to roll back because you can just switch the load balancer back to the old server group, unless it's actually been torn down already. But if not, you can really quickly switch back. Now, you also have something called rolling blue-green or rolling red-black. And there you kind of use a validation phase to switch your instances over one by one. Okay, so you use the individual instances and you label them to be picked up by the load balancer or not. Okay, this can be pretty easy to achieve in most clouds. For instance, with Kubernetes, you can use labels and selectors. Right, and then we have something more advanced, and that's called Canary. Does anyone know canaries, by the way? I see like 4 guys, all right. So the idea of the canary testing is, it dates back to the time we were working in the mines. And sometimes in the mines there are dangerous gases that we can't smell, so we take a canary bird down, and the canary bird is much more susceptible to these gases. So the canary bird would die, but then the workers would go back up and they would be safe. Okay, it's too bad for the canary bird. I hope there are no bird lovers in the audience, but at least it's not the workers that are dying, right? So that's the same idea. We're going to expose a limited set of users, or just a small percentage of the traffic to this new functionality we're trying to release. And we're going to measure this. We take a lot of metrics. We're going to pass this into a Canary Analysis, which will automatically determine whether these metrics from the Canary instances are better or at least the same as the one that we're trying to replace, the production instances. Right? And if we see that things are going well, we roll out to the next percentage. If we see that things are going bad, we just easily roll back, right? Because it's all automated. And that's something that I will demo today. I think it's been a month or something that this is really possible to do from Netflix, because they're really good at that, and they open sourced it, so we'll see that. Aside from the strategies, we have to make sure that we automate all the things, right? So here you can see an example of a pipeline that you can actually build in Spinnaker, and it's taking an image from testing environment, it's deploying it as a canary, then it's having a manual cutover. So it's a manual approval by some manager or something, so someone who can look at the instance and see if it's okay. Aside from the canary, of course, having to wait 30 minutes allows them to see if there's some kind of impact after a certain time frame, so that you don't have a limited view on just the startup time, because that might have a distortion. And then after that, you do a deployment to production in a blue-green or red-black fashion, and then you tear down the canary. You wait 2 hours to make sure that everything's fine, and then you destroy the old version of production. Okay, so you could actually switch back up until the 2 hours, and then you have to redeploy the old version if you would want to switch back. Okay, so Spinnaker kind of helps you with this. These things are normally not that easy to achieve. You can build that in Jenkins, for instance, in scripts, fine. But if you really want to do this in a deterministic way, then it's important to take into account all the different side cases. And Spinnaker kind of does a lot of stuff. So if you look at, for instance, the deployment to production in a blue-green fashion, Spinnaker does all this stuff for you. So it's just the one deployment. It has a couple of steps that it will automatically do. The first one will be to deploy in default, and then it will shrink the cluster in a blue-green fashion. So we'll shrink the I suppose it's a blue cluster then. It will disable it and it will scale it down. And when you disable the cluster in Spinnaker, it does a number of tasks. These tasks are, for instance, determining the health providers, disabling the cluster itself, monitoring it, caching, refreshing, then waiting for the disablement and refreshing the cache again. And when you disable a cluster, it does some operations, and these are actually the important parts that you would put into your Jenkins script, for instance. That's changing the forwarding rules, the targeting pools, and removing the instance. So all this stuff is handled for you out of the box, and that's a powerful tool to have, I think, especially if you want to do this at companies that might not have the cloud experience on board. Then this is actually a really easy way to get that started. Okay, and another principle that whatever tool that you choose should kind of look into is to have integration, operational integration between the deployment side and the operational side. So if you're deploying, it's interesting to see what you're causing in production, what kind of impact you have, and make decisions during your deployment phase on whether to continue or roll back. We've seen the blue-green analysis, we've seen the rolling blue-green analysis, we've seen the Canary analysis. Those things are kind of looking at production, what's currently happening, and making informed decisions on that. And that's, I think, it's a crucial part of making sure that your deployments are safe and are smart and predictable and repeatable and all that stuff. So that's one way of integrating, but you can also look at it the other way around. The operational phase, so if you're in production, might also be interested in how the deployment went, right? So you might want to be able to go back to the Git commit, for instance, of that specific deployment, or for instance, if you have a certain pipeline that you pass through and there was some manual approval of or whatever, it's interesting to look at when something's going wrong on production, what actually happened during that pipeline. Okay, who made those decisions? What was the process? And maybe iterate on that so you don't have a similar issue on production next time. Okay, so those are some principles that I think kind of combined make up a good tool to have continuous delivery or continuous deployment to production. In the cloud, of course. All right, so let's take a look at what Spinnaker can do, right? Spinnaker is a tool from Netflix. Okay, it's originally built by Netflix. It used to be called Asgard, and then they rebuilt it completely. And it's been open sourced, and it's heavily supported by Google, but also by Microsoft, Pivotal, Oracle. So you can imagine the major clouds supporting it, but also some retailers and some big companies that are contributing. Those companies are using it, are actually contributing to it, and these companies are, for instance, using it. There's actually a ton more. I couldn't fit them all on the slide, but there's really there's a lot of community activity going on there. And if you look at the clouds that it supports, it doesn't actually list all of them. So you have Amazon, obviously, because Netflix is doing everything on Amazon. You can also run it on OpenStack. You can do it on Azure or Oracle Cloud, and on Google Cloud with Kubernetes, or Kubernetes without Google Cloud. And you can also, I think, run it on OpenShift, although I've seen it only through OpsMX, which is proprietary, but still it's possible, and on Cloud Foundry as well. So if you're running any of those platforms, if you have any of these clouds, you can use Spinnaker. And you can combine them, obviously. You can have an application which runs on a number of these clouds, and you can combine them in a single view with a single pipeline, for instance. So how does this work? So the internal structure, it's written in Java. I'm not sure if there's many Java developers here, but this is Spring Boot. It's a very popular framework right now, and it allows you to have configuration convention over configuration, basically. So it does a lot of stuff for you. It's very highly opinionated, but it's really easy to get going, and allows you to have some kind of microservice architecture itself, right? So what do these things do? You have Deck, which is an Angular application. That's the browser-based UI. You have Gate, which is an API gateway. The Orca is an orchestration framework, orchestration engine. We have Cloud Driver, which is like a gateway to the cloud providers. Hold on, let me check. Roscoe is a bakery, right? The bakery for images on all the clouds. You can kind of bake images, kind of make them immutable. Then you have Igor. Where's Igor? Over there. Igor is integrating with continuous integration pipelines or with jobs from Jenkins, for instance, or Travis. We've got Echo. Echo is an eventing bus. It allows you to integrate with SMS, with Slack, HipChat, email, for instance. So that's the responsibility of Echo. Fiat is used for authorization, so you can have role-based access control, of course. And Halyard over there is a configuration engine, which gets you up and running really quickly. So you can kind of just configure what you want to have in Spinnaker, and it would just kind of deploy to, for instance, Kubernetes or whatever, right? And then you have one more, which is Kayenta, and Kayenta over there is the Canary Analysis engine. So that one will compare metrics from a metrics provider and it will check whether it's a good deployment or a bad deployment. Okay, so Spinnaker is all about making sure you can go fast to production, but you can still do that in a safe way. Okay, having speed reckless speed is not a good idea. But often, if we want to go faster, we kind of need to make kind of compromises on either safety, whether we can be sure that everything's going as expected, or we make a compromise in the other way, where we go slower because we want to have some manual testing or whatever. So the safety is baked in here and allows you to still go fast. And one of the things I was talking about in the things that we learned is that you have to have easy rollbacks, and Spinnaker offers this in a really easy way. You just click a button, and you can supply a reason if you want to, and you can restore to whatever version of the service is still running. Okay, and it will tell you what kind of operations it will execute. Now, you know that rollbacks are often under duress, right? So you're kind of stressed out when you want to do rollbacks, and you often have to do some manual tasks. Now, this is telling you what it will do for you. And this resizing, for instance, if you have to do that manually, you kind of have to bring the old version back up and then switch over. So you have to manually check whether these instances are healthy or are fine to be switched over to. This is all done automatically, and normally that's something that can go wrong, or there's a number of things that could go wrong when you're under a lot of stress and you have to do things manually. So just clicking a button, that's the way Spinnaker allows you to do it. Then also deployment windows, I was also talking about that, right? Well, if you see this graph, for instance, of your traffic, you can say, I want to have deployments between this time frame and this time frame every day of the week. And then you can just enter it in Spinnaker like that. Aligned between your business hours, for instance, or whatever. And if you have SPS, I think that's not open source by Netflix, you can couple that to your traffic metrics. Another interesting thing. Do you guys know about chaos monkeys? Yeah, that's cool, right? This is baked in as well, because chaos monkeys are from Netflix as well. Netflix built this stuff, so it was easy for them to integrate it. They have some kind of some chaos engineering platform, CHAP, which is not open sourced yet, I suppose. But this one is. So the Chaos Monkeys, if you're running on Amazon, that's really easy to use. But nowadays, Chaos Monkeys work on every major platform. So you can allow Chaos Monkeys to be part of your pipeline or part of your application to make sure that if you're in production, you kind of have these Chaos Monkeys running around and pulling plugs, right? It's a little bit dangerous, I suppose, for banking sectors or whatever. But that's a good way to make sure that your developers, think about these edge cases and things that might go wrong. If they know that this thing is going to happen, they're much more incentivized to kind of work on it and make sure that it can cope with it, that it's resilient. Okay, so you can kind of configure this in a really easy way. And then when I was talking about Canary Analysis, this is what Netflix kind of built back in the day, like when Spinnaker was first released. That was already in there, but it wasn't open sourced. So now they open sourced it, we can use it, and I have it in my demo. And the analysis kind of looks like this if you take a long time, because this runs from 12:30 until I think 2:30, right? So you have kind of a long time frame there, and you have a lot of metrics because of that. Obviously, during our demo, we won't have that much time, and I'll have to kind of get around that, but we'll make it work. You can have a lot of different metrics that you can measure in the Canary Analysis. For instance, CPU, error requests, incoming TCP connections, latency, all kind of latency with the percentiles, load average, successful requests, threads. That I would watch out with threads, of course. And this TCP in checks, if anyone knows what that means, please help me, but I don't know. So that's a lot of stuff, and there's probably more that you can measure. Also business metrics. If a button, for instance, has been clicked in the past like 100 times a minute, and all of a sudden it's not clicked anymore from now on in our Canary, that kind of might mean that there might be some issue with that button or with the page that it's shown on. might give you some meaningful information about whether this canary is actually working without having to do end-to-end tests all the time, right? Because end-to-end tests are slow, and this allows you to be in production from the start, be it for a small number of people, your canaries, but still it's part of that continuous deployment, right? So that we're going to see in action. There's more stuff that allows you to build in more safety. Spinnaker has a feature called cluster lock-in, which allows you to make sure that a certain cluster in Spinnaker is an abstraction for a number of server groups, which can be of separate versions, but it's the same application, the same image. So cluster lock-in, what this does is it kind of takes the cluster of these instances and it will lock it for an operation to be performed on it. If you go this fast, it could be that you trigger a pipeline twice right after each other because you're making 2 commits, for instance, and every commit can go to production, let's say. Then it passes all the tests and it will act on the same resources. And that could give you unreliable results, right? Because you're kind of mutating something which is already being mutated. That's difficult. So that kind of prevents that. It also has the ability to make sure you can't have concurrent pipeline execution. So that's also a useful one, that you have to wait for the first commit to completely finish the deployment before you can deploy the second commit. Some traffic guards, an important one as well. I think we will show that in the demo as well. So if you have an application running in production, then having all these deployment strategies, that's nice. But if you fail in one of these strategies, and you might roll back something or you might destroy some clusters, which are actually critical for production traffic, which might get you into a situation where you don't have any instances running on production for your application, well, that would be disastrous, right? So that's something we really want to prevent. So whatever the team might be configuring in its pipelines and be executing, the traffic guard will kind of kick in once you're trying to remove the last server group, for instance. Okay, so that's built-in feature as well. Manual judgments are an important step as well for making sure the gut feeling is also accounted for. That's an important thing to have. I think you can only measure that much with Canary Analysis and with all these automated tests. You're still going to have some kind of a positive impact, I think, if you have a person still validating it. And that's where the manual judgment comes in. And there's some guy who can actually just click a button and say, okay, this is fine for us, let's go. I'm going to use this for my demo as well. This might also be something, someone who's actually authorized to execute the pipeline. Could be that some people who are not authorized might start a pipeline, and then at some point, when you're actually pushing it to production, there might be someone who's has elevated permissions to click that button and make sure, okay, this is now fine, right? Maybe you have to synchronize with some marketing campaign or something, who knows, right? So these things are also useful to have. Then the conditional pipeline and stage execution, that's also for safety, because then you can maybe run more post-process operations, or you can have more tests triggered by a certain outcome of a pipeline. For instance, if the canary is not necessarily like 100%, it could also be maybe 85%. You could say, okay, from that point, conditionally, we're going to have another manual judgment to see if it's really good or not. Okay, because it wasn't really conclusive. And also notifications, of course. We saw there was a little service specifically for notifications as well. So you can send notifications through SMS or Slack or whatever. I wouldn't use email because people are getting spammed by email anyway. And if something goes down, I think an SMS or something, that's a better way to do it. Or PagerDuty or whatever. Okay, so we also have one more thing. The Halyard service. That was for configuration and deployment lifecycle management. So it's really easy using that tool to install, upgrade, and configure and validate your Spinnaker installation. And it uses some kind of bill of material. So there's a lot of services there, and they have their own versions. So what you can do is you can use Halyard to just figure out what the right versions are, how they're working together correctly, and just have Halyard do all that stuff. Okay, so what's coming up for Spinnaker? There's already available better config management for Kubernetes. So Kubernetes right now, we're going to see we're going to use a UI-driven approach for configuring our Kubernetes resources, but you can also use the manifests of Kubernetes themselves. You can even store that in Git and then have some kind of pub/sub or whatever mechanism to publish new changes to those manifests, and it will actually trigger a pipeline with these manifests as deployment artifacts. Right? So better config management is coming up, and it's already available in beta. And of course, throughout the entire time of Spinnaker, we're going to focus on the stability and operability. And the Spinnaker CLI now allows you as well to have pipelines as code. At least that's coming up. So that's an important part because, who's using Jenkins here? Anyone using Jenkins? Yeah, so you're probably using these the configuration as code as well to process it to Git. Right, so this is also coming for Spinnaker. And rolling blue-green strategy, you can already use it, but it's also in beta. And declarative CD, it's an interesting one as well. So normally we would kind of describe what we want to deploy in our pipeline, each step we want to do. And that's more like an imperative way of working. Declarative CD kind of gives Spinnaker the ability to, aside from imperative, so you can still switch back, but for declarative, you have the ability to kind of just tell Spinnaker, just like with Kubernetes, what state you want to achieve in the end. And Spinnaker will figure out how to deploy it, what kind of tests to run, what kind of Canary Analysis to do. You don't have to worry about that. Okay, so that's what Spinnaker wants to focus on for companies that kind of want to have that paved road, for teams that are not really familiar with all these different steps and these stages and these strategies. And of course, some monitoring aside from the stability and operability as well. So Armory is one of the companies that are having a commercial offering for Spinnaker as a service. And that kind of defines these different stages of continuous delivery. And as you can see, there's on the far right side, there's a bunch of these practices like automated canaries or the chaos engineering that are actually included in Spinnaker. So Spinnaker kind of allows you to make these steps from stage 1 all the way to stage 5 in a really easy way. And I've seen that at some of my clients where we use Spinnaker and we still use it. It's just so easy to get people who have no experience whatsoever with cloud to get running things in our cloud environments. And I think that's an important thing to have. We're not all Silicon Valley companies, right? So that's it's a really easy tool to use in that sense. All right, so back to the slide, the demo now. The demo is basically, it's kind of based on Rick and Morty. Does anyone know Rick and Morty? Wow, I think it's the most people here I've ever seen. Great. So Rick and Morty is a show, a television show. Maybe I'll just show a screenshot of it. These guys, right? Rick and Morty. So there was another talk just before me about Spring Cloud Stream, was also about Rick and Morty. So I'm kind of continuing on that. That's my use case. I'll have, in my Rick and Morty use case, I'll have Pickle Rick. Pickle Rick is the version of Rick as a pickle, and he just doesn't want to go to therapy, so he transforms into a pickle, so he can't go to therapy, obviously. And then there's another character I'd like to introduce, which is Meesix. Mr. Meesix, we already saw that as well in the previous talk, but Mr. Meesix is kind of your ghost that can perform any wish you want, and then once it's performed, it will disappear or it will die. So it really wants to die quickly, and you see this guy, he's being alive for quite some time. So we're going to use some Meesix in our application. The problem with Meesix is that they will kind of try to achieve their goal of fulfilling your wish, but they will actually use their own kind to help them. So they will spawn more Meesix to help you achieve your goal. So in the end, you'll end up with a whole lot of Meesix, and that's dangerous. This just keeps on spawning. So in our demo, we're going to see that we have one version, which is the Pickle Rick version, the green version, right? Blue-green deployment, you see? And you have the blue version, which is Meesix, and we don't want that many Meesix, so we're going to try to make sure automatically that if we have too many Meesix, that we're going to roll back the pipeline. Okay, and that we're going to do with automatic Canary Analysis. Right, so that's the basic setup. I'm going to use a little Spring Boot application here as well. It's just really simple. If you're not familiar with Java, it's a super simple application. It's available on GitHub, so you can try this out yourself as well. For the entire demo, I would also have a code lab on a blog post. So if you just follow me on Twitter or go to the links at the end of the presentation, then you will also have that information. So what do we have here? We have a Spinnaker demo application, which prints out a couple of characters in the logs. Right, it's super simple. These are all kind of characters from the show, but there's one character that kind of wants to duplicate, and that's the me6, right? So we'll have some me6 every 20 seconds, right? Because it's scheduled with a fixed delay. But that should be fine, unless in the demo controller, which will be the endpoint we'll be calling, unless we have more me6 being printed in the logs, right? That's dangerous. So we're going to enable that in our next version, and we're going to see what the automated Canary Analysis will do with that. Okay, so I'm going to use you guys as well as my canary birds to make sure that there's enough traffic to have a meaningful decision at the end of our first interval. All right, so let's change something, right? So I have the same thing here. I don't know if it's readable. So there's one thing here. It's in HTML, and it shows you a background image of Pickle Ricks or of me6. So I'm gonna change this to me6, voila, and I'm going to change the controller. So this could be a simple change that you do any time of the day. Maybe just make a simple change, but you might have this unwanted effect of having something go wrong. And if you have this automatic Canary Analysis to look for that, then that's going to prevent you from pushing this to production. Okay, so I'm just going to push this. Right, there we go. Okay. So, yep, that's good. Now, let's take a look at our application. So, currently we have two applications. We have a dev version and we have a production version. So, on dev, this is our version. It's the green version of Pickle Rick, and it's working fine. And on production, we have as well Pickle Ricks. So, looking at Spinnaker, this is Spinnaker. We can model pipelines. I have to actually open the connection. So there's an SSH tunnel I set up so I don't have to expose it on some kind of DNS. Now I'm already making calls, but it's not yet being piped. Hold on. Depends a bit on the Wi-Fi, I suppose. There we go, success. Okay, now we're piping all these ports. And yeah, it works. So here, basically, this is the pipeline. It's going to be triggered by a new Docker file or no Docker image in the registry. So let's see how that will work. We have here Google, which can do some kind of building for me. So I have a trigger here, which has push to any branch, and push to any branch will make a new image for me. 1 minute ago, there was a new image being a new build. I'm sorry. This is not, these are the images. So this is the build. The build's now finished. So what it will do, it will just do a Maven install, which is the build system, and it will do a Docker build, which makes an image for me, and it will push it to the registry. So let's see in the registry what we got now. So in the registry, we got Spinnaker demo, and there we got a new one just now being pushed. I don't know if that's visible, but yeah, so it's 24cc, that's the tag. So let's go look into Spinnaker here. If we configure the first pipeline, what I actually put in here is that I'm going to look for the GCR EU. So my registry, I'll look for the application at any tag, should be fine. I can also put in some notifications that will be triggered once the pipeline is finished. So that will actually trigger a deployment. Let's see if that actually happened. Sometimes it's a bit slow to refresh. That's depending on the cache, on the Wi-Fi, of course. All right, let's just continue checking what it does. So deployment, yeah, it's actually triggered a pipeline. So deployment will go to Kubernetes, it will label it as dev because we're deploying to dev. This could be, of course, a different cluster altogether, a different Kubernetes cluster, but I'm using the same one for both the dev and prod for the demo purposes. I'm checking for this container, and where does the container come from? Under container, you can see it's actually getting it from the image from trigger. So it will get that from the registry, it will use that image, and it will use it to deploy. I'm deploying to port 8080, and I'm using the Highlander strategy. Does anyone know what the Highlander strategy is? Any guesses? Yes, there can only be one, exactly. So it will chop off the heads of all the other instances, and it will only remain one. Okay, so that's what it will do, and then it will have a manual judgment to check whether the application is running as expected. So let's check this pipeline. So here we have the deployment running, and as you can see, these are kind of these steps that I was going through when I was talking about automation, right? So the tasks that it was doing, it's creating the server group, it's monitoring it, it's waiting for the application to go up. Then it's disabling the old cluster. So if I go to application to infrastructure, as you can see now, the old version here is disabled and the new version is up. So 13 is disabled, 14 is up. This also gives me a chance to talk about this infrastructure view. This gives you a holistic view of all your application being deployed on all your clusters across all your cloud environments, all your accounts, and all your regions. So you can get a real good sense of where your application is. Right? If you're running on 5 different clouds, they will all show up here. And you can use all these 5 as part of, in one pipeline, you can use all these 5 clouds. So it's going to disable it. There can only be one, right? So after a while, it will make sure it's disabled and it will get rid of it. So the manual judgment will then ask me whether to check whether the application is running as expected. And here, where are we right now in task status? Okay, so this one finished. The disabling worked. Now we're going to shrink it, so we're going to remove it. First, we disable the instance. That means we're going to remove it from the load balancer. So if we want to roll back at that point, it's still possible. But we want to have only one instance in the end, so we're also going to remove it. So now rollback is harder. Right? So here, this should finish now. Okay, now gives me a question. Manual judgment, check whether the application is running as expected. I can continue or stop, but let's first check, right? So on the cluster, I have the demo dev. I can go to this instance. I can, for instance, check the logs if I want to see if everything's working as expected. As you can see, all the characters are being printed once in a while, right? So after 20 seconds, they're all being printed. As this is a regular scenario. And I have a load balancer on top, which I exposed with an external IP. So this one here is the same as this one. Now it's our Me6, right? So Me6 took over and dev, the deployment is successful. So this is the same link. Now it's become Me6. Of course, in production, we still have the same version, right? Great. So what's next? We have to approve or decline. Yes, sometimes the call doesn't come true. So you have to continue. And what will this do? It will start the next pipeline, which is deployed to production. So it's already really busy. So the configuration here is not a registry trigger, but it's a trigger based on the pipeline that I just ran. It has to be successful, and this will be triggered. Great. So now we're going to find, let's start with this one. We'll find an image from development environment, so the one that we just deployed. We're going to find which version this is. If you have to do this in Jenkins, in a Jenkins file, it gets pretty tricky because you have to have the right version deployed on the cloud at this instance, not just the one that you got from the previous script. Once that's found, you can deploy a Canary, and the Canary, it will be similar deployments to the previous one on dev, but it will use a different stack, prod, and it will use a detail called Canary. So we can identify this specific one as the Canary version. We will find the image from dev, obviously. We'll use that container that we found there, or the image, and we will not have a strategy because we want to deploy it next to the existing one. Once we've deployed it, we put it on the same load balancer as regular production. So if you go to production, you will have a certain percentage. I think it's 1/3 chance of getting to the Canary. Okay, you can kind of have any kind of routing mechanism influencing how many percentage, what percentage goes to this Canary, of course. So that's kind of the idea here. And then you're going to do a Canary analysis. And the Canary analysis will be running in real time. So I shouldn't forget, now that we are doing the Canary analysis, I'm going to fake some load as well, because otherwise I noticed that there's not enough. Okay, it's actually being faked by my load test here. Really crazy load test. I'm making some calls, and as you can see, there are now some pickle rigs and me6. And I invite you guys to help me out here as well, because I saw that sometimes this isn't enough. So if you please would go to this link here, either the IP address or this link, you can go to production, just my production environment as well. And we're going to just make sure there's enough traffic here to make sure that the me6 are kind of evaluated as bad, okay? Because what are these me6 doing? They're printing more me6. Every time you go to the website, to that page, you're printing me6 in the logs, and that will give us the opportunity to check the logs in an automated way and make sure that this is a site. This is not actually what we want, right? That we can divert from this error scenario. So if you go to this link, I hope it's still working, because I just created this morning, but it works. Great. So then you go here, and if you refresh here, right, sometimes you see me6. There we go. Okay, so why is this? Because if I go to infrastructure now, there's some more stuff being provisioned here. So we have the production of obviously the production instances. They are still running with one turned down, so we can easily still go back to the version 1 with a rollback. Let me just show that real quickly. You can roll back here, right? And you can roll back to version 1 if you want. And that's still spinned up, so that's really easy to do. But talking about the Canary, here we have a Canary now. And if you look at the load balancer on production, they're all served by the same load balancer. Now, I didn't talk about the baseline yet. If you want to spin up a Canary, then it's kind of important to make sure you're not measuring something that's just been spinned up and compare it to something you've been measuring for maybe days, weeks, months, right? Because after time, your instance might kind of diverge, and they kind of might become a little bit less performant, for instance. Maybe there's some small memory leak or whatever. What we want to do is make sure that we have a baseline, which is the same version as production, current production, and spin that up next to the Canary one and use those two to measure. Give them the same kind of traffic, and you can actually have a kind of comparable result, right? So that's the idea. So that was what we were doing here in the pipeline as well. You might have noticed already. We deploy the Canary, but we also could deploy a baseline. Okay, so from that point on, we do the Canary analysis, and what do we do here? We kind of say it's real time, so we want to test right now. So please keep refreshing and keep checking the me6, kind of try to get them out there, and then we can kind of check every 5 minutes if this is going well or not. Right, so this is what we're going to do. I don't know how long I've been talking, but after 5 minutes of doing this test, we will have our first result. We will do this for an entire hour, because otherwise you wouldn't have enough data to make an informed decision. But we'll just try to make it fail after 5 minutes already. We'll have a step of 60 seconds, which means it will have metrics every 60 seconds. All right, so what else is interesting here? It's the scoring threshold. So we'll have a marginal score of 75, which means if any of these intervals, any of these analysis that happens in between, it goes below 75, boom, we're going to fail, right? If it's between 75 and 100, it's fine, continue. But in the end, it has to be above 95 to be able to be a successful deployment. Okay, so let's look at our pipeline here. How long have we been running? We've been running for 5 minutes, yes, and we are now running our first Canary. Great. So I'll just refresh. Well, the Canary analysis takes about 15 seconds. There we go. So let's see. The first one, 100. Is that good? Let's check the results here. So I have a bunch of logs here. A bunch of metrics. I have the me6 logs. I have the memory, and I have the CPU. I kind of configured that. So with CPU, I see it's kind of similar. It's just 0.2% difference, so that's fine. And the memory, if this one kind of goes crazy, but if you look at the histogram, it kind of it kind of has the same weights there. It kind of has the same values in the end. And we'll see that across after a certain amount of time, it will start to behave exactly the same way. So for now, we're still fine, and we're going to pass, apparently, unfortunately. But if we look at the MEE6 here, we see that the canary in blue is, in fact, a lot higher than the baseline. But Spinnaker says, let's give it another 5 minutes and make sure that this is not just a startup anomaly, right? And that's kind of a problem with this demo, because we kind of have normally a couple of hours to test this. And sometimes this kind of fails right away because it's more different. So let's look at some other examples here. I'm sure I have one. Yeah, here. So here you have, for instance, hold on, I have to be in the right pipeline. Yeah. The Canary Analysis here. That kind of failed after the first one because I was really spamming it that time. Maybe now I didn't spam it enough. And then you can see here in this one, this particular place, that it has not enough data to make to have that comparison, so it will fail, or it will be too many MEE6, right? So if we wait another 3 minutes, I don't know if I have that time.
No, unfortunately, we're out of time.
Yeah, okay, so I'll finish up. So after that, if you see that if you have the same amount of MEE6 in the logs, I have this as an example of the previous deployment. What you can see here is that the Canary result has 100%, and that in the end, you get something like this, right? So here the CPU is very similar, although it's noticed the spike here, so it's labeling it as high, but it's not enough to fail it. For the MEE6 logs, we saw that it was the same for both, because we weren't deploying a MEE6, we were deploying also a pickle rick. So 60-60. And for the memory, we also saw here that it was in a predictable fashion. So it wasn't maybe exactly the same, but it was also going at the same rate. So that meant that the MEE6 was fine. And after 5 minutes, I'm 100% sure it will fail. So that's kind of that was kind of the demo. That kind of the whole Canary Analysis can be a really great tool to help you to have safer deployments and to have fast deployments. The combination of those two is I think, a really good tool to have, right? After this, by the way, it will do a teardown of the canaries, but that will just be destroying those clusters. All right, so just a quick 1 more minute. Thanks. So if you want to know more about it, there's this book, Continuous Delivery with Spinnaker. It's been released last week or 2 weeks ago, and it has a lot of information about this. And if you have any questions, you can always reach me at Andreas Evers on Twitter, or you can check our blog over there, which will have the code lab in there. So if there's any questions, I think it will be outside or yes. During lunch. You can find me here. But I want to thank you guys for coming, and hopefully you had a great time. Thanks, guys.